This video provides an overview of IBM's multi-level security capability as demonstrated in a proof of concept leveraging space data that comes from another proof of concept that was developed called the Space Situation Awareness Proof of Concept. A high-level depiction of that proof of concept is provided here with this slide. Essentially what's happening is different data is brought together that helps provide density information and real-time analytics on the impact of that space density on orbiting bodies to improve the ability to perform surveillance and command and control actions on those orbiting bodies. As you see in the bottom right-hand corner, the data associated with that real-time analytics proof of concept is then provided as a ingestion data set for the multi-level security system and proof of concept, and operators and operational personnel on both networks, on a high-level network in a command post and a lower-level network, mobile network, are leveraging and taking advantage of those enclaves of protected information in each of the enclaves. In this particular example, on the high side, it's sensitive but unclassified satellite data, and then the mobile subscriber, in this case the commander, with his mobile device is able to get a subset of that information. On the next slide is a depiction in this particular demonstration that you'll see the full set of satellite data streams being accessible by the user demo 3 that simulates the orbital analyst in the command center. A little bit later you'll hear that being discussed as NA Command, which is North American Command Center. You'll also then hear about demo 4, user demo 4. You'll hear about access NA Mobile, NA Mob, which is the mobile access privileges. And then lastly, that particular actor would be the commander for the access to that enclave, that protected enclave of data. And lastly, in this scenario, is a coalition analyst that is not having access to this U.S. only subset of data. Next, we'll be getting a deeper representation or presentation of how the technology is working, data ingested from the real-time analytics proof of concept, and then handled in a common criteria compliant architecture that provides common criteria compliant protection of these separate logical partitions, and provides those presentation tier to, in this case it'll be Google Earth as the common presentation tier for each of the environments. So Gary will next provide an overview of the rest of the demonstration, how that was all implemented and how those access methods are implemented. Gary?
So we began the actual demonstration by showing our Windows Explorer. These are our various driver files. We select the driver file NACMD, which contains data for all of the satellites. As you can see, when we double click on it, we launch Google Earth, which is primed with the NACMD file. And as we expand that file by clicking on this twisty to the left, we can see the data for all of the satellites. Once we tick the check mark, we're then asked which user identity we'd like to use for this particular invocation. So in actual practice, there's various ways of identifying users or terminals, but for this proof of concept, we've chosen to use user certificates, which we can select for each of our proof of concept choices. So here we select user demo 3, our most privileged user, and as we can see here, the Google Earth is now contacting our mainframe and has retrieved data for all of the satellites. We can click on the information for a particular satellite, and Google Earth brings us to the data for that particular satellite, including the labeled track. Now, next thing we need to do is close Google Earth, because unfortunately Google Earth once you select an identity for a particular invocation, it remembers that identity, and we need to use different identities. So we close Google Earth. This time we double click on the NAMOB, our least privileged user, and the driver file for that user shows only the satellites to which that user has access. In this case, satellites F through K. We can see Google Earth has been primed with our file, and when we expand the twisty, we see only satellites F through K. When we give the check mark, tick the check mark, and then select our identity user 4, we can now see that Google Earth has contacted the mainframe and populated data for the satellites to which we have access. Now, suppose a friend of ours sends us the driver file for all of the satellites, but we only have access as the least privileged security label, we only have access to satellites F through K. So let's close Google Earth and see what happens in that scenario. We're clicking here on NACMD, our most privileged driver file. As you can see in Google Earth, when we bring it up, that we have labels for all of the satellites. As soon as it comes up, we'll be able to see that. And here we go, we see the labels for all of the satellites. However, as user demo 4, we only have access to satellites F through K. So let's select our user ID as demo 4 and see what happens. As you can see here, we're contacting the mainframe for data on all of the satellites. The mainframe has automatically blocked our access to satellites A through E, to which we don't have access, while supplying data for satellites F through K, the ones to which we do have access. And finally, we'll just do a demonstration showing access all the satellites, but we're going to select this time user 5, who does not have access to any of the satellites, and we'll see what happens when that unauthorized user attempts to gain access to our satellite data. So Google Earth is coming up again, and because we double clicked on NACMD, Google Earth has primed itself with data, with drivers for all the satellites. This time we select demo 5, and as you can see shortly, we don't have access to any of the satellite data because user 5 does not have access. This concludes our brief demonstration.